Welcome to ExHub MCQs channel. Dive into chapter electricity with 100 expert-crafted MCQs to boost your understanding and exam success. MCQ 1. What is the SI unit of electric current? Option A, volt. Option B, ampere. Option C, ohm. Option D, joule. The correct answer is option B, ampere. Explanation. The SI unit of electric current is the ampere, named after André-Marie Ampère. 1 ampere is equal to the flow of 1 coulomb of charge per second. This is a fundamental unit in the study of electricity. MCQ. Which device is used to measure electric current in a circuit? Option A, voltmeter. Option B, ammeter. Option C, rheostat. Option D, galvanometer. The correct answer is option B, ammeter. An ammeter measures electric current in a circuit. It is connected in series with the circuit element to ensure the entire current flows through it, providing accurate readings of current. MCQ 3. What happens to a circuit if the switch is turned off? Option A, current flows. Option B, bulb glows. Option C, current stops. Option D, resistance increases. The correct answer is option C, current stops. Explanation. Turning off the switch breaks the circuit, stopping the flow of electric current. This prevents the devices connected to the circuit, such as bulbs, from operating. MCQ 4. What is the direction of conventional current? Option A, same as electron flow. Option B, opposite to electron flow. Option C, random. Option D, along the conductor's length. The correct answer is option B, opposite to electron flow. Explanation. Conventional current flows from the positive to the negative terminal of a battery, which is opposite to the actual electron flow. This direction was established before the discovery of electrons. 5. What is the formula for electric current I? Option A, I equals V multiplied by R. Option B, I equals Q multiplied by T. Option C, I equals Q divided by T. Option D, I equals R divided by V. The correct answer is option C, I equals Q divided by T. Electric current is the rate of flow of charge through a conductor. It is calculated by dividing the charge in coulombs by the time in seconds. MCQ 6. The SI unit of potential difference is named after which scientist? Option A, ampere. Option B, volta. Option C, ohm. Option D, joule. The correct answer is option B, volta. Explanation. The volt, the SI unit of potential difference, is named after Alessandro Volta, the Italian physicist who invented the voltaic pile, a precursor to the modern battery. MCQ 7. Which device maintains a potential difference in a circuit? Option A, resistor. Option B, battery. Option C, ammeter. Option D, rheostat. The correct answer is option B, battery. Explanation. A battery maintains the potential difference across a circuit by converting chemical energy into electrical energy. This ensures a continuous flow of charge in the circuit. MCQ 8. What is Ohm's law? Option A, V equals IR. Option B, V equals I divided by R. Option C, V equals R divided by I. Option D, V equals I squared multiplied by R. The correct answer is option A, V equals IR. Explanation. Ohm's law states that the potential difference across a conductor is directly proportional to the current flowing through it, provided the temperature remains constant. MCQ 9. What is the resistance R if the potential difference is 220 volts and the current is 2 amperes? Option A, 110 ohms. Option B, 220 ohms. Option C, 440 ohm. Option D, 100 ohms. The correct answer is option A, 110 ohms. Explanation. Using Ohm's law, R equals VI, substituting V equals 220 volts and I equals 2. Amperes gives R equals 220 over 2 equal to 110 ohms. MCQ 10. Why is nichrome used in electric heaters? Option A, high conductivity. Option B, low resistivity. Option C, high resistivity. Option D, magnetic properties. The correct answer is option C, high resistivity. Explanation: nichrome is used in electric heaters due to its high resistivity and excellent heat tolerance. It can withstand high temperatures without oxidizing or melting, making it ideal for heating applications. MCQ 11. What does a voltmeter measure? Option A, current. Option B, resistance. Option C, potential difference. Option D, heat. The correct answer is option C, potential difference. Explanation: a voltmeter measures the potential difference voltage between 2 points in an electric circuit. It is always connected in parallel across the component where the voltage is to be measured. MCQ 12. What is the unit of electrical resistance? Option A, volt. Option B, ampere. Option C, coulomb. Option D, ohm. The correct answer is option D, ohm. Explanation: the unit of electrical resistance is the ohm, symbolized by omega. It is named after Georg Simon Ohm, who formulated Ohm's law, relating resistance, voltage, and current. MCQ 13. How is the resistance of a conductor affected by its length? Option A, directly proportional. Option B, inversely proportional. Option C, unaffected. Option D, quadratically proportional. The correct answer is option A, directly proportional. Explanation: the resistance of a conductor is directly proportional to its length. A longer conductor has more material to resist the flow of current, increasing the total resistance. MCQ 14. What happens to resistance if the area of cross-section of a wire is doubled? Option A, remains constant. Option B, doubles. Option C, halves. Option D, triples. The correct answer is option C, halves. Explanation: resistance is inversely proportional to the area of cross-section of a wire. Doubling the area decreases the resistance by half, as more paths for current flow are created. MC 15. Which factor does not affect the resistance of a wire? Option A, material. Option B, length. Option C, area of cross-section. Option D, voltage. The correct answer is option D, voltage. Explanation: resistance is determined by the material, length, and cross-sectional area of the wire, but is not influenced by the voltage applied across it. Voltage affects current, but not the wire's inherent resistance. MCQ 16. What is the SI unit of electrical resistivity? Option A, ohm. Option B, ohm meter. Option C, ampere meter. Option D, voltmeter. The correct answer is option B, ohm meter. Explanation: the resistivity of a material is measured in ohm meters, not m, which quantifies the material's ability to resist the flow of electric current. It is a characteristic property of the material. MCQ 17. What type of resistors are used in electrical heating devices like toasters? Option A, low resistivity metals. Option B, alloys. Option C, insulators. Option D, high conductivity metals. The correct answer is option B, alloys. Alloys, such as nichrome, are used in heating devices due to their high resistivity and ability to withstand high temperatures without oxidizing. This ensures efficient and durable heat generation. MCE. What happens to current if the resistance in a circuit is doubled? Option A, increases. Option B, decreases. Option C, remains unchanged. Option D, becomes zero. The correct answer is option B, decreases. Explanation: according to Ohm's law, I equals V var R, if the resistance doubles while the voltage remains constant, the current is halved because resistance opposes the flow of current. MCQ 9. How are resistors connected in a circuit to achieve the smallest possible equivalent resistance? Option A, series. Option B, parallel. Option C, both. Option D, none. The correct answer is parallel. Explanation. In a parallel connection, the reciprocal of the equivalent resistance is the sum of the reciprocals of individual resistances, reducing the total resistance significantly compared to a series connection. MCQ 20. What is the main disadvantage of a series connection of resistors? Option A, increased current. Option B, reduced voltage. Option C, failure of one affects all. Option D, high energy consumption. The correct answer is option C, failure of one affects all. Explanation. In a series circuit, if one resistor fails or is disconnected, the entire circuit is interrupted. This makes the configuration impractical for applications requiring independent operation of components. MQ 21. Which law states that the potential difference across a conductor is proportional to the current? Option A, Ohm's law. Option B, Joule's law. Option C, Kirchhoff's law. Option D, Faraday's law. The correct answer is option A, Ohm's law. Explanation. Ohm's law states that the potential difference across a conductor is directly proportional to the current flowing through it, provided the temperature remains constant. This is expressed as V equals IR, where R is the resistance. MC 22. What is the formula for power dissipated in an electrical circuit? Option A, power equals current squared multiplied by resistance. Option B, power equals current multiplied by resistance squared. Option C, power equals voltage squared divided by resistance. Option D, both A and C. The correct answer is option D, both A and C. Explanation. Power dissipation in an electrical circuit can be calculated using P equals I to R or P equals V over R, derived from Ohm's law. Both formulas are used to calculate energy loss as heat in resistive components. MC 23. Which material is commonly used for filaments in electric bulbs? Option A, copper. Aluminium. Option C, tungsten. Option D, nichrome. The correct answer is option C, tungsten. Explanation. Tungsten is used for bulb filaments because of its high melting point, 383 Celsius, and excellent resistance to heat. These properties make it suitable for producing light efficiently without melting. MCQ 24. Why are alloys preferred over pure metals in heating elements? Option A, higher conductivity. Option B, do not oxidize at high temperatures. Option C, lower resistance. Option D, cheaper than metals. The correct answer is option B, do not oxidize at high temperatures. Explanation. Alloys like nichrome are used in heating elements because they resist oxidation even at high temperatures. This property makes them durable and reliable for long-term use in appliances like toasters and irons. 25. Which quantity determines the rate at which energy is delivered by a current? Option A, voltage. Option B, resistance. Option C, power. Option D, current. The correct answer is option C, power. Explanation. Power measures the rate at which energy is delivered by a current. It is calculated using P equals VI, which indicates how much energy is consumed or transferred per unit of time in an electrical circuit. MC 26. What happens to the resistance of a metallic conductor as its temperature increases? Option A, increases. Option B, decreases. Option C, remains constant. Option D, first decreases, then increases. The correct answer is option A, increases. Explanation. The resistance of a metallic conductor increases with temperature due to more frequent collisions between free electrons and atoms. These collisions impede the flow of current, increasing resistance. MCQ 27. How is electric current defined? Option A, rate of charge flow. Option B, rate of voltage flow. Option C, rate of energy transfer. Option D, resistance in a conductor. The correct answer is option A, rate of charge flow. Explanation. Electric current is the rate at which charge flows through a conductor. Mathematically, it is expressed as I equals QRT, where Q is charge in coulombs, and T is time in seconds. MCQ 28. How does the resistivity of a material vary with its temperature? Option A, increases. Option B, decreases. Option C, remains constant. Option D, depends on the material. The correct answer is option D, depends on the material. Explanation. The resistivity of a material depends on its type and temperature. Metals generally show an increase in resistivity with rising temperature, while semiconductors exhibit a decrease in resistivity as temperature increases. MC 29. In a parallel circuit, how is the total current related to the branch currents? Option A, equal to the smallest branch current. Option B, equal to the largest branch current. Option C, sum of the branch currents. Option D, independent of branch currents. The correct answer is option C, sum of the branch currents. Explanation. In a parallel circuit, the total current is the sum of the currents through all branches. Each branch carries a portion of the total current, depending on its resistance and the voltage across it. MC 30. What is the advantage of connecting devices in parallel in domestic circuits? Option A, increased voltage. Option B, independent operation. Option C, reduced current consumption. Option D, higher resistance. The correct answer is option B, independent operation. Explanation. In parallel connections, devices operate independently. If one device fails, others continue to function. Additionally, all devices receive the same voltage, ensuring proper operation across the circuit. MC 31. What is the commercial unit of electrical energy? Option A, Joule. Option B, option C, kilowatt hour. Option D, ampere. The correct answer is option C, kilowatt hour. Explanation. The commercial unit of electrical energy is the kilowatt hour, kilowatt hours. 1 kilowatt hours represents the energy consumed when a device with a power rating of 1 kilowatt operates for 1 hour. It is equal to 3.6 times 10 to the 6 joules. MCQ 32. Which material has the lowest resistivity among conductors? Option A, silver. Option B, option C, aluminium. Option D, tungsten. The correct answer is option A, silver. Explanation. Among conductors, silver has the lowest resistivity, approximately 1.60 times 10 to the m. Its excellent conductivity makes it the best conductor of electricity, but its cost limits its use in most applications. MCQ 33. What happens when resistors are connected in series? Option A, current increases. Option B, total resistance increases. Option C, voltage remains constant. Option D, current remains constant. The correct answer is option B, total resistance increases. Explanation. When resistors are connected in series, their resistances add up. This increases the total resistance, reducing the current flow for a given applied voltage. MCQ 34. Which formula is used to calculate the heat produced in a resistor? Option A, heat equals current squared multiplied by resistance and time. Option B, heat equals current multiplied by resistance squared and time. Option C, heat equals voltage squared multiplied by resistance and time. Option D, heat equals current multiplied by resistance. The correct answer is option A, heat equals current squared multiplied by resistance and time. Explanation. The heat produced in a resistor is calculated using Joule's law, H equals I to RT, where I is current, R is resistance, and T is time. This explains the heating effect of electric current. MCQ 35. How does the total resistance in a parallel combination of resistors compare to individual resistances? Option A, larger than the largest resistance. Option B, equal to the largest resistance. Option C, smaller than the smallest resistance. Option D, equal to the smallest resistance. The correct answer is option C, smaller than the smallest resistance. Explanation. In a parallel combination, the total resistance is smaller than the smallest individual resistance. This is because parallel connections provide multiple paths for current, reducing overall resistance. 36. Why is copper widely used in electrical transmission lines? Option A, high resistivity. Option B, high conductivity. Option C, low density. Option D, high melting point. The correct answer is option B, high conductivity. Copper is widely used in electrical transmission lines due to its high electrical conductivity and low resistivity. It efficiently carries current with minimal energy loss, making it suitable for power distribution. MCQ 37. What is the effect of using a thicker wire in an electric circuit? Option A, increases resistance. Option B, decreases resistance. Option C, no change in resistance. Option D, increases voltage. The correct answer is option B, decreases resistance. Explanation: thicker wires have a larger cross-sectional area, reducing resistance. This allows more current to flow through the circuit, improving efficiency and reducing heat loss. MCQ 38. What is the melting point of tungsten, commonly used in bulb filaments? Option A, 2,000 degrees, 3,000 degrees. Option C, 13,380 degrees. Option D, 2,500 degrees Celsius. The correct answer is option C, 3,380 degrees. Explanation: tungsten has a melting point of 3,380 degrees Celsius, making it ideal for use in bulb filaments. Its high melting point allows it to emit light at high temperatures without melting. 39. What happens to the equivalent resistance when more resistors are added in parallel? Option A, increases. Option B, decreases. Option C, remains constant. Option D, oscillates. The correct answer is option B, decreases. Explanation: adding more resistors in parallel decreases the equivalent resistance. This happens because additional pathways for current flow reduce the overall opposition to the flow of electric charge. MCQ 40. Why is a fuse used in electric circuits? Option A, to increase current. Option B, to decrease resistance. Option C, to prevent overcurrent. To measure voltage. The correct answer is option C, to prevent overcurrent. Explanation: a fuse prevents overcurrent by breaking the circuit when current exceeds a safe limit. The fuse wire melts due to the heat generated, protecting appliances from damage and reducing fire risks. MCQ 41. What is the relationship between current and resistance according to Ohm's law? Option A, directly proportional. Option B, inversely proportional. Option C, unrelated. Option D, constant D. The correct answer is option B, inversely proportional. Explanation: according to Ohm's law, current I is inversely proportional to resistance for a constant voltage. As resistance increases, current decreases, and vice versa, expressed mathematically as I equals V by R. MCQ 42. Which quantity remains constant in a series circuit? Option A, current. Option B, voltage. Option C, resistance. Option D, power. The correct answer is option A, current. Explanation: in a series circuit, the current remains constant throughout because there is only one path for the charge to flow. The same current flows through all components connected in series. MCQ 43. What happens to power dissipation if the current in a circuit doubles? Option A, halves. Option B, doubles. Option C, quadruples. Option D, remains constant. The correct answer is option C, quadruples. Explanation: power dissipation is given by P equals I to R. If the current doubles, power increases by a factor of 4 as it is proportional to the square of the current. 44. What is the primary purpose of a rheostat in an electric circuit? Option A, to measure current. Option B, to increase voltage. Option C, to vary resistance. Option D, to decrease power. The correct answer is option C, to vary resistance. Explanation. A rheostat is a variable resistor used to control the current in an electric circuit by adjusting the resistance. This allows fine-tuning of devices like lights or motors without changing the voltage. MCQ 45. Which resistor configuration provides the highest equivalent resistance? Option A, all in series. Option B, all in parallel. Option C, a mix of series and parallel. Option D. The correct answer is option A, all in series. Explanation. Resistors connected in series have their resistances added together. This results in the highest equivalent resistance, as the total opposition to current flow is the sum of all individual resistances. MCQ 46. How does the heat generated in a circuit change if resistance is doubled, keeping current constant? Option A, halves, hobbles. Option C, quadruples. Option D, remains unchanged. The correct answer is option B, doubles. Explanation. Heat generated is given by H equals I square RT. If resistance doubles while the current remains constant, the heat generated also doubles because heat is directly proportional to resistance. MCQ 47. What is the potential difference if 100 joules of work is done to move 5 coulombs of charge? Option A, 5 volts. Option B, 10 volts. Option C, 20 volts. Option D, 25 volts. The correct answer is option B, 10 volts. Explanation. Potential difference is calculated using V equals W or Q. Substituting W equals 100 J and Q equals 5 C, V equals 100 phi equals 10 V. This shows the energy per unit charge in the circuit. CQ 48. Which configuration of resistors is preferred in domestic wiring? Option A, series. Option B, parallel. Option C, series parallel hybrid. Option D, single wire connection. The correct answer is option B, parallel. Explanation. Parallel configuration is preferred in domestic wiring because it allows devices to operate independently. Even if one device fails, the others continue to function and each receives the same voltage. MCQ 49. Why does the cord of an electric heater not heat while the element glows? Option A, cord has high resistance. Option B, element has higher current. Option C, cord has low resistance. Option D, element is insulated. The correct answer is option C, cord has low resistance. Explanation. The cord of an electric heater has low resistance, so it does not generate significant heat. The heating element, on the other hand, has high resistance, which converts electrical energy into heat efficiently. MCQ 50. What is the formula to calculate electrical energy consumed? Option A, energy equals voltage multiplied by current multiplied by time. Option B, energy equals current multiplied by resistance and time. Option C, energy equals voltage squared multiplied by time. Option D, energy equals current multiplied by time squared. The correct answer is option A, energy equals voltage multiplied by current multiplied by time. Explanation. Electrical energy consumed is calculated as E equals V times I times T, where V is voltage, I is current, and T is time. This formula is commonly used to determine energy usage in circuits. MCQ 51. Which property of a conductor opposes the flow of electric current? Option A, conductance. Option B, resistance. Option C, voltage. Option D, power. The correct answer is option B, resistance. Explanation. Resistance is the property of a conductor that opposes the flow of electric current. It depends on the material, length, and cross-sectional area of the conductor, and it is measured in ohms. MCQ 52. What is the resistivity of copper at room temperature? Option A, 1.60 times 10 to the minus 8. Option B, 1.62 times 10 to the minus 8. Option C, 2.63 times 10 megatext m. Option D, 6.84 times 10 minus 8. The correct answer is option B, 1.62 times 10 to the minus 8 text M. Explanation. Copper has a resistivity of approximately 1.62 times 10 to the minus 8 at room temperature. This low resistivity makes it an excellent conductor of electricity, widely used in electrical wiring. MCQ 53. Which device is used to measure the potential difference in a circuit? Option A, ammeter. Option B, voltmeter. Option C, galvanometer. Option D, rheostat. The correct answer is option B, voltmeter. Explanation. A voltmeter measures the potential difference across 2 points in an electric circuit. It is connected in parallel to the circuit component where the voltage is to be measured. MC 54. What is the effect of connecting resistors in parallel on total resistance? Option A, increases. Option B, decreases. Option C, remains constant. Option D, depends on voltage. The correct answer is option B, decreases. Explanation. Connecting resistors in parallel reduces the total resistance. This happens because the reciprocal of the equivalent resistance is the sum of the reciprocals of individual resistances, allowing more current paths. MCQ 55. What is the energy consumed by a 100-watt bulb in 5 hours? Option A, 500 watts. Option B, 500 J. 500 kilowatt-hour. Option D, 500 volts. The correct answer is option A, 500 watts. Explanation. The energy consumed by a 100-watt bulb in 5 hours is calculated as E equals P times T equals 100, text H equals 500, text W. This is equivalent to 0.5 kilowatt-hours. MCQ 56. Which material has the highest resistivity among insulators? Option A, glass. Option B, diamond. Option C, ebonite. Option D, paper. The correct answer is option C, ebonite. Explanation. Ebonite has very high resistivity, ranging from 1015 to 1017 omega text M. This makes it an excellent insulating material, commonly used to prevent current leakage in electrical applications. MC 57. How does resistance change if the length of a wire is halved? Option A, doubles. Halves. Option C, remains constant. Option D, becomes 0. The correct answer is option B, halves. Explanation. Resistance is directly proportional to the length of the wire. If the length is halved, the resistance also decreases by half because there is less material for the current to pass through. MC 58. What happens to current if the voltage across a resistor is tripled while resistance is constant? Option A, increases by 3 times. Option B, remains the same. Option C, decreases by 3 times. Option D, doubles. The correct answer is option A, increases by 3 times. Explanation. According to Ohm's law, I equal VR, if the voltage V is tripled while the resistance R remains constant, the current I also triples. MC 59. What is the primary cause of the heating effect of electric current? Option A, resistance of the conductor. Option B, voltage. Option C, length of the conductor. Option D, cross-sectional area. The correct answer is option A, resistance of the conductor. Explanation. The heating effect of electric current is caused by the resistance of the conductor. When current flows through a resistor, energy is dissipated as heat due to collisions between electrons and atoms. MCQ 60. What is the advantage of using tungsten in bulb filaments? Option A, high resistivity. Option B, high melting point. Option C, low resistivity. Option D, low thermal expansion. The correct answer is option B, high melting point. Explanation. Tungsten is used in bulb filaments because it has a very high melting point, 308 degrees Celsius. This allows it to emit light efficiently at high temperatures without melting, making it ideal for electric bulbs. MCQ 61. What does the term potential difference refer to in an electric circuit? Option A, energy per unit charge. Option B, current per unit time. Option C, resistance per unit length. Option D, voltage per unit power. The correct answer is option A, energy per unit charge. Potential difference refers to the work done to move a unit charge from one point to another in an electric circuit. It is measured in volts and represents the energy transfer between 2 points. MCQ 62. Which factor does not affect the resistivity of a material? Option A, temperature. Option B, material type. Option C, length. Option D, atomic structure. The correct answer is option C, length. Explanation. Resistivity is a material property and depends on its type, temperature, and atomic structure. It does not depend on the length or size of the material, as those factors influence resistance, not resistivity. MCQ 63. What is the resistance of a wire if its resistivity is 1.5 times 10 to the power of minus 8 ohm meter, length is 2 meter, and area is 1 square millimeter? Option A, 0.03 ohm. Option B, start 0.15. Option C, 0.03. Option D, 0.3 ohm. The correct answer, option A, 0.03 ohm. Explanation. Using the formula, resistance equals resistivity multiplied by length divided by area, substituting resistivity equals 1.5 times 10 to the power of minus 8, length equals 2 meter, and area equals 1 times 10 to the power of minus 6 square meter, we get resistance equals 0.03. MCQ 64. Which type of circuit provides the same voltage across all components? Option A, series. Option B, parallel. Option C, series parallel hybrid. Option D, open circuit. The correct answer is option B, parallel. Explanation. In a parallel circuit, all components are directly connected to the voltage source. This ensures that the voltage across each component is the same, irrespective of the other component's properties. MCQ 65. Why does a bulb filament glow when current flows through it? Option A, due to high resistivity. Option B, due to low voltage. Option C, due to high conductivity. Option D, due to low melting point. The correct answer is option A, due to high resistivity. Explanation. A bulb filament glows because its high resistivity causes it to heat up when current flows through it. The heat makes it reach incandescence, emitting light without melting. M66. What happens to the resistance of a material if its temperature is decreased? Option A, increases. Option B, decreases. Option C, remains constant. Option D, doubles. The correct answer is option B, decreases. Explanation. For most materials, especially metals, resistance decreases as temperature decreases. This is because lower temperatures reduce collisions between electrons and atoms, allowing current to flow more freely. MC 67. How is energy dissipated in a purely resistive circuit? Option A, as light, as sound. Option C, as heat. Option D, as current. The correct answer is option C, as heat. Explanation. In a purely resistive circuit, all electrical energy is converted into heat due to resistance. This is explained by Joule's law, which states heat equals current squared multiplied by resistance multiplied by time. MCQ 68. What is the equivalent resistance when two 10-ohm resistors are connected in parallel? Option A, 20 ohm. Option B, 5 ohm. Option C, 10 ohm. Option D, 2 ohm. The correct answer is option B, 5 ohm. Explanation. For parallel resistors, the formula is 1 divided by total resistance equals 1 divided by resistance 1 plus 1 divided by resistance 2 kilo. Substituting both resistances as 10 ohm, the total resistance is 5 ohm. MCQ 69. Why is the series arrangement not used in domestic circuits? Option A, increases voltage. Option B, reduces current. Option C, failure of one component affects all. Option D, high energy loss. The correct answer is option C. Failure of one component affects all. Explanation. In a series arrangement, if one component fails, the entire circuit is interrupted. This makes it unsuitable for domestic wiring, where independent operation of devices is necessary. MC70. What is the purpose of using nitrogen and argon in electric bulbs? Option A, to increase brightness. Option B, to reduce filament evaporation. Option C, to conduct electricity. Option D, to improve resistance viewers. The correct answer is option B, to reduce filament evaporation. Explanation. Nitrogen and argon gases are used in electric bulbs to prevent filament evaporation. These inert gases create a protective environment, prolonging the filament's life and reducing oxidation at high temperatures. MCQ 71. What is the formula for calculating resistance in terms of resistivity, length, and area? Option A. Resistance equals resistivity multiplied by length multiplied by area. Option B. Resistance equals resistivity multiplied by length divided by area. Option C. Resistance equals area divided by resistivity multiplied by length. Option D. Resistance equals resistivity divided by length multiplied by area. The correct answer is option B. Resistance equals resistivity multiplied by length divided by area. Explanation. The formula for resistance is R equals rho L divided by A, where R is resistance, rho is resistivity, L is length, and A is cross-sectional area. This equation explains how the material, shape, and size of a conductor affect its resistance. MCQ 2. What is the reciprocal of resistance called? Option A, conductance. Option B, capacitance. Option C, inductance. Option D, reactance. The correct answer is option A, conductance. Explanation. The reciprocal of resistance is called conductance, which measures how easily electric current flows through a conductor. It is expressed in Siemens S and calculated as G equals 1 divided by R. What happens to the brightness of bulbs in a parallel circuit if one bulb burns out? Option A, all bulbs stop glowing. Option B, brightness increases. Option C, brightness decreases. Option D, brightness remains the same. The correct answer is option D, brightness remains the same. Explanation. In a parallel circuit, each bulb operates independently. If one bulb burns out, it does not affect the brightness of the remaining bulbs, as they are connected directly to the same voltage source. MCQ 74. What is the unit of electrical energy used in households? Option A, watt. Option B, kilowatt hour. Option C, joule. Option D, ampere. The correct answer is option B, kilowatt hour. Explanation. Electrical energy in households is measured in kilowatt hours, kilowatt hour. 1 kilowatt hour represents the energy consumed by a 1 kilowatt appliance operating for 1 hour, which is equal to 3.6 million joules. MCQ 75. How does a fuse protect an electric circuit? Option A, increases resistance. Option B, breaks the circuit during overcurrent. Option C, reduces voltage. Option D, stores electrical energy. The correct answer is option B, breaks the circuit during overcurrent. Explanation. A fuse protects an electric circuit by melting when current exceeds a safe limit. This breaks the circuit, preventing damage to appliances and reducing the risk of fire caused by overheating. MCQ 76. What is the relationship between voltage and current in a purely resistive circuit? Option A, voltage leads current. Option B, current leads voltage. Option C, voltage and current are in phase. Option D, voltage and current are opposite. The correct answer is option C, voltage and current are in phase. Explanation. In a purely resistive circuit, voltage and current are in phase, meaning their peaks and zero crossings occur at the same time. This indicates no phase difference between them. MCQ 77. Which resistor configuration reduces total resistance? Option A, series. Option B, Option C, both A and B. Option D, neither A nor B. The correct answer is option B, parallel. Explanation. A parallel configuration reduces the total resistance because the reciprocal of the equivalent resistance is the sum of the reciprocals of individual resistances, creating multiple current paths. MC 78. What is the equivalent resistance when two 5-ohm resistors are connected in series? Option A, 2.5 ohm. Option B, 5 ohm. Option C, 10 ohm. Option D, 15 ohm. The correct answer is option C, 10 ohm. Explanation. In a series connection, the total resistance is the sum of individual resistances. For two 5-ohm resistors, R total equals R1 plus R2, which is 5 plus 5, resulting in 10 ohm. MCQ 79. What is the primary application of Joule's heating effect? Option A, electric motors. Option B, electric bulbs. Option C, electric heating devices. Option D, transformers. The correct answer is option C, electric heating devices. Explanation. Joule's heating effect is used in devices like electric heaters, toasters, and irons. It converts electrical energy into heat when current flows through a high-resistance element, producing useful thermal energy. MQ 80. Why are copper and aluminum wires used in power transmission? Option A, high resistivity. Option B, low cost. Option C, high conductivity. Option D, high melting point. The correct answer is option C, high conductivity. Explanation. Copper and aluminum wires are used in power transmission because of their high conductivity and low resistivity. They efficiently carry current with minimal energy loss and are suitable for long-distance power distribution. Q81. What is the power dissipated in a resistor if the voltage is 10 volts and the resistance is 5 ohms? Option A, 20 watts. Option B, 10 watts. Option C, 25 watts. Option D, 2 watts. The correct answer is option C, 25 watts. Explanation. Power is calculated using the formula P equals V squared divided by R. Substituting Schachter V equals 10 volts and R equals 5 ohms, we get P equals 10 squared divided by 5, which is 100 divided by 5, resulting in 25 watts. MCQ 82. What happens to the equivalent resistance when identical resistors are added in series? Option A, increases. Option B, decreases. Option C, remains constant. Option D, becomes 0. The correct answer is option A, increases. Explanation. When resistors are added in series, the total resistance increases as the sum of individual resistances. This is because there is only one path for current flow, and each resistor adds to the opposition. 83. How is the current in a circuit affected if the resistance is halved while voltage is constant? Option A, doubles. Option B, halves. Option C, remains constant. Option D, triples. The correct answer is option A, doubles. Explanation. According to Ohm's law, I equals V divided by R sto. If resistance is halved while voltage remains the same, then current doubles as resistance is inversely proportional to current. MCQ 84. What is the primary advantage of parallel circuits over series circuits? Option A, constant resistance. Option B, independent operation of Option C, reduced voltage. Option D, increased current flow. The correct answer is option B, independent operation of devices. Explanation. In parallel circuits, each device operates independently. If one device fails, others continue to function. Also, all components receive the same voltage, ensuring proper performance. MCQ 85. What is the SI unit of electric power? Option A, Joule. Option B, watt. Option C, option D, ampere. The correct answer is option B, watt. Explanation. The SI unit of electric power is the watt, denoted as W. 1 watt is defined as the power consumed when 1 ampere of current flows under a potential difference of 1 volt. MCQ 86. Which factor determines the amount of heat generated in a conductor? Option A, current. Option B, voltage. Option C, resistance. Option D, all of the above. The correct answer is option D, all of the above. Explanation. Heat generated in a conductor is determined by current, voltage, and resistance, as described by Joule's law, which states H equals I squared multiplied by R multiplied by time. MCQ 87. What is the equivalent resistance of 3 resistors, 6 ohms, 12 ohms, and 18 ohm, connected in parallel? Option A, 2 ohms. Option B, 3 ohms. Option C, 4 ohms. 6 ohms. The correct answer is option B, 3 ohms. Explanation. For parallel resistors, the formula is 1 divided by total resistance equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Substituting R1 equals 6 ohms, R2 equals 12 ohms, R3 equals 18 ohms, we get total resistance equals 3 ohms. MCQ 88. Why is nichrome used in electric heating elements? Option A, low cost. Option B, high conductivity. Option C, high resistivity. Option D, high melting point. The correct answer is option C, high resistivity. Explanation. Nichrome is used in electric heating elements due to its high resistivity, which generates significant heat when current passes through it. It also has good mechanical strength and resists oxidation at high temperatures. MCQ 89. What is the relationship between power, voltage, and current? Option A, power equals voltage squared multiplied by current. Option B, power equals voltage multiplied by current. Option C, power equals current squared divided by voltage. Option D, power equals voltage divided by current. The correct answer is option B, power equals voltage multiplied by current. Explanation. Electrical power is calculated using the formula P equals V multiplied by I, where P is power, V is voltage, and I is current. This formula represents the rate at which electrical energy is transferred. MCQ 90. What happens to the resistance of a metallic conductor as its temperature increases? Option A, increases. Option B, decreases. Option C, remains constant. Option D, becomes 0. The correct answer is option A, increases. Explanation. As the temperature of a metallic conductor increases, its resistance also increases. This is because higher temperatures lead to more frequent collisions between free electrons and atoms, which hinder the flow of current. MCQ 91. What is the potential difference across a 4 ohm resistor when a current of 3 amperes flows through it? Option A, 12 volts. Option B, 8 volts. Option C, 24 volts. Option D, 6 volts. The correct answer is option A, 12 volts. Explanation. Using Ohm's law, V equals I multiplied by R. Substituting I equals 3 amperes and R equals 4 ohms, we get V equals 3 multiplied by 4, which is 12 volts. MCQ 92. What is the SI unit of resistivity? Option A, ohm. Option B, ohm meter. Option C, ampere meter. Option D, volt. The correct answer is option B, ohm meter. Explanation. Resistivity is measured in ohm meters. It quantifies how strongly a material opposes the flow of electric current and is a characteristic property of the material. MCQ 93. Which device is used to vary resistance in an electric circuit? Option A, voltmeter. Option B, ammeter. Option C, rheostat. Option D, galvanometer. The correct answer is option C, rheostat. Explanation. A rheostat is a variable resistor used to adjust resistance in an electric circuit. By changing the resistance, it controls the current flow, making it suitable for dimming lights or adjusting motor speeds. MCQ 94. How does the total resistance in a series circuit compare to individual resistances? Option A, equal to the smallest resistance. Option B, equal to the largest resistance. Option C, sum of all resistances. Option D, less than any individual resistance. The correct answer is option C, sum of all resistances. Explanation. In a series circuit, the total resistance is the sum of all individual resistances. Current flows sequentially through each resistor, increasing the overall opposition to current flow. 5. What is the primary purpose of a fuse in a circuit? To conduct electricity. Option B, to reduce voltage. Option C, to prevent overheating. Option D, to store charge. The correct answer is option C, to prevent overheating. Explanation. A fuse protects the circuit by melting when current exceeds a safe limit, breaking the circuit and preventing overheating. This safeguards appliances and reduces fire risks. MCQ 96. What is the equivalent resistance when three 10-ohm resistors are connected in parallel? Option A, 3.33 ohms. Option B, 5 ohms. Option C, 10 ohms. Option D, store 30 ohms. The correct answer is option A, 3.33 ohms. Explanation. For parallel resistors, the formula is 1 divided by total resistance equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, Leo. Substituting R1 equals R2 equals R3 equals 10 ohms, we get total resistance equals 3.33 ohms. MCQ 97. What does a voltage current graph for a resistor obeying Ohm's law look like? Option A, parabolic. Option B, straight line. Option C, exponential. Option D, circular. The correct answer is option B, straight line. Explanation. A VI graph for a resistor obeying Ohm's law is a straight line passing through the origin, indicating that voltage is directly proportional to current when the temperature is constant. What happens to current if voltage is constant and resistance increases? Option A, increases. Option B, decreases. Option C, remains constant. Option D, doubles. The correct answer is option B, decreases. Explanation. According to Ohm's law equals V divided by R. If resistance increases while voltage remains constant, the current decreases, since resistance opposes the flow of current in a circuit. MCQ 99. Why are alloys like nichrome preferred in heating devices? Option A, low conductivity. Option B, high resistivity. Option C, high melting point. Option D, cost effectiveness. The correct answer is option B, high resistivity. Explanation. Nichrome is preferred in heating devices due to its high resistivity, which allows it to generate heat efficiently. It also resists oxidation at high temperatures, making it durable and effective for applications like electric heaters and irons. MCQ 100. What is the power consumed by a 200-watt appliance used for 2 hours? Option A, 200 watt-hours. Option B, 400 watt-hours. Option C, 2,000 watt-hours. Option D, 600 watt-hours. The correct answer is option B, 400 watt-hours. Explanation. Power consumed is calculated as P multiplied by T. Substituting P equals 200 watts and T equals 2 hours, we get energy equals 200 multiplied by 2, which is 400 watt-hours. Thank you for watching ExHub MCQs channel. We hope this session on electricity helped you strengthen your concepts and prepare effectively. In this video, we covered 100 multiple-choice questions with detailed explanations, covering key topics like Ohm's law, resistors, circuits, power dissipation, heating effects of current, and electrical energy consumption. Understanding these concepts is essential for excelling in physics exams and real-world applications. If you found this video helpful, don't forget to like, share, and subscribe to our channel for more high-quality MCQs on various subjects. Stay tuned for upcoming chapters where we will break down complex topics into easy-to-understand MCQs with clear explanations. For any doubts or additional explanations, feel free to drop a comment below. We would love to hear your feedback and suggestions for future topics. Keep learning, stay curious, and keep practicing with ExHub MCQs channel. See you in the next video. Happy learning.